Let's talk about architecture.
I'm sorry.
Yeah.
I just have a quick question about the wildcard index.
Yeah.
Does that add more cost, or are all the indices pretty much the same?
They're roughly the same,
Okay.
and it's kind of funny. This is in a small group setting. This is the second time I've really talked about it, and every time it's the same question, right? Are they expensive? And it's not it's more of a, I should just preemptively say, hey, it's not that much more expensive, right? Yeah, you're welcome. Okay. We were having a conversation at lunch, and we were talking about the architecture of Mongo compared to what we're used to from an architecture standpoint in the relational world, right? Mongo is a distributed node system. If you haven't worked with a distributed node system before, they're kind of non-intuitive. And the things that we learned in the relational world and a lot of the patterns that we have don't necessarily map straight over. Okay? In a distributed node system, the node is the smallest architectural unit, and we symbol nodes together in different configurations to give ourselves different capabilities. Okay? If you are thinking about your system at the node level, when we're talking from a data modeling standpoint, you're probably going to freak yourself out. Okay? You want to be thinking about it at the cluster level. And we'll sort of talk about that, and we'll talk through that. Right? You end up with a lot of nodes very fast. And if your muscle memory is, I've got one cylinder for production, and maybe another cylinder that's a backup database, okay? And now you come to me and you go, okay, so here's the deal. You're going to have 15 nodes, 15 cylinders that make up this cluster. You're sitting here going, why are there so many databases in the system? This is insane. Get the heck out of here, right? You've got to take a step back and look at it. I have a cluster that I can read off of secondary nodes, but all the details of the cluster are hidden from me. And this will make more sense as we go further. Okay. This is as much as I want to talk about CAP theorem. So, no, we need to talk about it in passing. So, CAP theorem is one of those things that we like to pretend doesn't exist, but it does. And there's a lot of math behind it. But you kind of need to be aware of some of the fundamental pieces of it. Basically, the theory is this. You can be highly available, okay, so all the clients can read and write. You can be highly consistent, all the data is the same everywhere, and you can have partition tolerance. In other words, when the network breaks between them, things continue to work. You can only at any given moment be two of those three things. Okay? And chasing down, trying to figure out which one of those you want to be can drive you slowly mad. Right? For the record, Mongo goes after consistency and partition tolerance. In other words, the data is the same, and it doesn't fall down when you start breaking the network. Okay? You can get to a point with a Mongo cluster that if you lose enough nodes, you can no longer write. And we'll talk about that when we talk about high availability. Okay? But you can also design your cluster in such a way that to get to that point, so many other bad things are happening that this is the least of your worries. Okay? Okay, just by point of reference, and really what I want you to get out of all this is that everybody is using nodes. So Redis has a concept of a master database. For high availability, we have a master and slave. For clustered, we start adding them in. And for highly available, we start just adding them in. Okay. Neo4j, we've got a node. We start bringing them together into a cluster. And that's how we get consistency, okay, and scale up. The point on that is, and I could have done Hadoop, I could have done Couch, I could have done a whole bunch of, could have done Dynamo. when you're looking in the NoSQL space, you're talking about nodes coming together at scale to do stuff. Okay? So whether it's Mongo, whether it's somebody else, you're going to be having to deal with the complexity of nodes. Right? The good news is that the Mongo tooling abstracts all the complexity away, and we'll talk about that. If you were going to go with something like Cosmos, your developers are exposed directly to the core of the architecture. Right? Now, Microsoft makes this sound like a good thing. Remember, developers are masochistics, right? They want that pain. But the problem is that if you are not an expert in multi-node distributed architectures, and an expert in consistency, and an expert in the query languages that you're dealing with Cosmos, on day one, you will be making mistakes that are very, very expensive, okay? As opposed to the Mongo approach where we hide the complexity behind the driver. Right? A little compare and contrast. For all this talking about nodes, though, the question we need to start with is, what is a node? Okay. So, if we take all the marketing out of the equation, a node in Mongo is a BSON file read-write machine that essentially is three components. There's a listener component. The listener has a sense of self. It has a sense of group. It has a sense of state. It has a sense of status of the queries that are being asked of it. There's an indexing scheme